Okay, here's section 6.5. This is going to be the last parallelogram section that we do. So the things we're going to talk about today, we're going to talk about two different figures. Both of them are parallelograms. And I've got one already pre-made. Let me grab that one right there. I'll copy it and paste it. Now this looks just like a regular parallelogram, doesn't it? But when I made this thing, when I first originally made this thing, what do you think might be true about this? Does it look like anything's different about this than a normal parallelogram? That looks like a square to you? It used to be a square? I guess a lot of things used to be a square and you make it into this thing, but look at this. What do you think might be true about the sides of these things? They're equal to each other, okay? Now you can't tell for sure, but I'm telling you right now, when I made it, I made all four of those sides equal to each other. So that's given, okay? So I'm giving you that all four of these sides are equal to each other. Everybody with me so far? So if you have a quadrilateral with, let me think. Yeah, I think I can just say quadrilateral. If you have a quadrilateral with all four sides equal to each other, that's going to automatically make this a parallelogram. How do I know that's a parallelogram just by saying all four sides are equal? Well, I don't know anything about the angles yet, but I do know that all four sides are equal, so that means the opposite sides, these two opposite sides are equal, right? And then, of course, these two opposite sides would be equal. So that's enough to make it a parallelogram. Remember we said if you can show that the opposites, or both pairs of opposite sides are equal to each other, then it's a parallelogram. So if I told you that all four sides are equal to each other, that automatically makes this a parallelogram, doesn't it? Now, this is a little bit of a special parallelogram because all four sides are equal. It's not just these two and these two are equal, but all four of them are equal. Look at this fly. I'm going to kill that thing. Oh, man. Laying around in my head. All right. Must like my fresh cut. That's probably what it likes. Good landing spot. All right, let's take a look. If all four sides are equal, we give this a name, and this is a little bit of a different name, isn't it? It's probably not a name that you used when you were a little kid, but as you get older, you start seeing these things, and it's called a rhombus. Okay, R-H-O-M-B-U-S. It's a rhombus, and what is a rhombus? Okay, it's basically a parallelogram, or you could actually say it's a quadrilateral, but the book says it's a parallelogram with what? Four equal, I'll tell you what, let's say equal or congruent sides. Alright, so it's a parallelogram and you got four equal sides. That's a rhombus. Everybody see that? So that's the definition of a rhombus. It's a quadrilateral or it's a parallelogram with four equal sides. All four sides are equal to each other. Does that make it a square? No. Okay, we're going to talk about a square in a minute, but this is not necessarily a square. Just because all four sides are the same does not mean that it's a square. Okay, but it is a rhombus. That's the definition of a rhombus. You good with that so far? Yeah, that's not too hard. Let's do this. Let's make this another color, and let's see what else might be true about a rhombus. Let me go in order here. Yeah, I thought they went right to the diagonals. Let's do this. Let's draw the diagonals of this rhombus. Now we know what is true about the diagonals of a parallelogram. On a regular parallelogram, the diagonals do what to each other? They bisect each other, and that's really the only thing that we know about the diagonals on a normal everyday parallelogram. But this is not a normal everyday parallelogram. This is a special type of parallelogram, and it's special because all four sides are equal, and it even has its own name. It's called a rhombus. Now, there's something else that's true about this. Now, do they bisect each other? Of course they do, because this is a parallelogram. So they do bisect each other, but there's two things that are special about these diagonals. Okay, we know that they bisect each other. What about, are they equal to each other? Are they equal to each other in length? Now, we did talk about a special parallelogram where the diagonals were equal to each other. But what was that? What figure was it when the diagonals were actually equal to each other? It's a rectangle. We just finished talking about that, okay, in the last lesson. So a rectangle, the diagonals are equal to each other. This is not a rectangle because there's not four right angles. So are the diagonals equal to each other here? No, they're not. Okay, but they do bisect each other because it's a parallelogram. But here's something else that's true. Look at the angle that they make right here where they intersect. What does it kind of look like it might be? Looks like a right angle there, doesn't it? And it absolutely is a right angle. Okay? So when is this only true? This is only true. The diagonals make a right angle right here only when it's the diagonals of a what? Of a rhombus. Okay? So if I do, so write that down. Let's all write it down. Everybody writing? No. So everybody write stuff down. Okay, if I have to physically get up and put a pencil in your hand and move your hand, I'm going to do it. All right, I'm serious. Get a pencil out and write this down. I was pretty nice about it Friday, or was it Friday or was it the other day? Might have been the other day. I think it was the other day. All right, and I still told you to write it down, but still people weren't writing. So I want you to write this down. So the diagonals of a rhombus. What's a good geometry word? We don't say make a right angle. What would we say? Are what? Perpendicular. Very good. That's a good geometry word that we're going to use right here. Are perpendicular. So write that down. All right, so the diagonals of a rhombus are perpendicular, which means it's a right angle right here. Okay? So that could really help you out, finding missing angles. They could say that this was like 30 degrees, or actually, what, that wouldn't be 30. Watch. What if they told you this was 60 degrees right here and they asked you for this angle?
30.
And you could tell that that's 30, right? Because 30 and 60 is 90, plus 90 is 180. So there's all kinds of stuff they could ask you. But you have to know that that's a right angle right there. Okay, they're not always going to draw it. They'll tell you that it's a rhombus. You have to know that that's a right angle. Okay, that's your responsibility to know that that's a right angle. All right, so that's one thing about the diagonals of a rhombus. Excuse me. Here's another thing that's true about the diagonals of a rhombus. That's not true about every other normal parallelogram. Normal, if you want to call it normal. I don't know if there is a normal one or not, but we'll just say that, just a regular old parallelogram. This next thing is not always true. Look at this diagonal and how it's what it's doing to this angle right here. It looks like it bisects, doesn't it? It looks like it's exactly equal to each other. Like this angle and this angle are exactly equal, and they are. When this is a rhombus, okay, it's only true when this is a rhombus. When this is a rhombus, the diagonals actually bisect the opposite angles. Everybody see that? So this angle and this angle are opposite angles. That diagonal bisected those two opposite angles, didn't they? Now remember, the opposite angles are also equal to each other because it's a parallelogram. So what must be true about this one here and this one here? All four of these are equal. So if I told you that this was 20 degrees, that's all I told you was that one little angle right there is 20. What could you figure out then? Well, you could figure out that's 20, and then this has to be what? 20, and this has to be 20. Agreed? What would this angle right up here be? If this was 20, what would this angle be right here? 70. Good, because this is 90, all right, and this is 20. This has to be 70, because 70 and 20 is 90 plus 90, right, is 180. Everybody follow me? So all I did was tell you that one little skinny angle right here, and you could actually tell me all of these angles just by knowing that one little angle right there. So if this is 70, that's 70. And of course down here is the same exact thing. Everybody got that? Look, this whole angle is what? 140, and this whole angle is 140. This whole angle right here is what? 40. What's 40 and 140? 180. Remember, consecutive angles are supplementary. It's all coming together, isn't it? See how it all works together? So everything we said before holds true about a rhombus. All right, so what do we know? What can we write down? We can also say that the diagonals of a rhombus, what do? They bisect. Now, how did we say that? They bisect what? All the angles? The opposite angles, right? They bisect the opposite angles. All right, so that means these two opposite angles are split right in half. Okay, if I told you this whole entire angle, you should be able to figure out both of these, right? Just take that and divide it by 2. Easy enough. So those are two things that are really important about a rhombus. That the diagonals are perpendicular, so they form a right angle, and they also bisect the opposite angles. That's not true about every single parallelogram. In fact, let me just draw a regular, ordinary parallelogram. and let's just see if it even looks true. I'll stretch this out just a little bit more just to make it a little more obvious. Watch this. If I made a diagonal from here to here and from here to here. Remember, on a rhombus, what do the diagonals do? They're perpendicular. Does that even look close to perpendicular? Not at all. Okay, so you see that the diagonals are not perpendicular on a normal everyday parallelogram. They're only perpendicular when you bring these two sides in and you get a nice rhombus, when all four sides are equal to each other. Everybody understand that part? Okay, so obviously that's not perpendicular. What about the bisecting thing? Look at this angle right here and look at this angle right here. They don't even look that close to each other, do they? Okay, that looks a lot smaller than that one right there. So there's no way that it bisects. So I just wanted you to visually see that on a normal parallelogram, neither one of those things is going to be true. It's only true when it's a parallelogram with all four right, or not four right angles, I'm sorry, with all four of the same sides. And what do we call that thing? It's called a what? It's a rhombus. What if we had two of these things? The plural of rhombus. Some people might say rhombuses, but we don't say rhombuses. The plural would be rhombi. Okay, I'll put a PL right here for plural. So if I talk about two, so the title of this lesson is called Rhombi and Squares, all right, because they're using the plural version of it. But one of them is just called a rhombus. Everybody got that? So rhombi is the plural if you have two or more, and rhombus is the singular. That's just one of them. All right. I think we've covered rhombus pretty well. Tell you what, let's do an example before we go to the next one. We got some time. We didn't take that long on the homework today. So, oops, I don't want that. I want that. Let me grab that rhombus. I'll copy and paste that one. All right, and let's put a couple diagonals in here. And let's give you some information. This is the kind of stuff you're going to see on the worksheets. Let's label it F, G, H, J, and K right here. All right. It says angle FJH. Where's FJH? That's this whole big angle right here. That's 82 degrees. 82 degrees. All right. So that's angle FJH. And then it also, it just says find angle KHG. Find angle KHJ, not G. There's no G in there. All right, KHJ. Well, let's see. Where is KHJ? Let's find it. KHJ, it's this angle right here. We'll make it yellow. Let's make it a little thicker so we can see a little better. Okay. So we got to find this angle right here. Well, where are we going to start? Remember, it tells you that this is a rhombus. All right, it tells you that this is rhombus FGHJ. This is a rhombus. So I know all four of these sides are equal to each other. And they're asking you to find this angle right here. You're trying to find this angle. We'll just call it X. Is that all right? Just to give it one letter. What do they tell you? They tell you this is 82. So if they tell you this whole big angle right here is 82, what does that tell you about some of these angles inside? They're equal to each other, and what are they both going to be then? Going to be 41. How'd you get 41? Divided 82 by 2. That's right, because you split it in half, didn't you? So this is what? 41. Is that my answer? Is that this angle right here? Is that angle and this angle the same? No. You could do a couple different things, but probably this way is the best. You know that's a right angle. How do you know that's a right angle? Because the diagonals are what? Perpendicular on a rhombus, right? So if this is 41 and this is 90, how do I find this? Well, this and you could do it that way, and that would be okay, but an easier way that these two are going to add up to 90, right? So the easiest way is just go 90 minus 41. And what's that? 49. So X, or angle KHJ, is 49 degrees. There you go. It's not so bad, is it? What's another way you could have done it? You could have looked at it like this. This whole thing is 82, right? So what would this angle right here be? Aren't they supplementary to each other? This big angle and this big angle, right? So you could have, now I kind of like the way that I did it first of all, but just in case you didn't see it, you could go this angle and this angle. You could go 180 minus what? 82. And what is that? That's 98. Is that right? So this whole big angle is 98. How do I find this part right here? It's half of 98. What's half of 98? It's 49. You still get it the same exact way, don't you? I'm sorry, you don't get it the same way, but you get the same answer. You just got it a different way, I should say. All right? Okay. All right. Let's go to the next thing. What's the title of this lesson? Rhombi and what? Squares. And you guys figure you know everything there is to know about squares, right? Well, maybe not so much. Well, what do we know about a square? Just from your experience, what do we know about a square? All the sides are equal. So guess what that makes it then? If all the sides are equal and it's a four-sided figure, guess what that makes it? It does make it equilateral. What's something we just talked about just a minute ago? What? Yeah, it does make it a parallelogram, but more specifically, a rhombus, right? It makes it a rhombus, right? Didn't we just spend all that time talking about a rhombus? Four-sided figure with all four sides equal to each other is a rhombus, right? So if we know already, just from our, just from growing up and knowing what a square is, we know that all the sides are equal to each other. But there's more to a square than just having all the sides equal to each other. What's also true about a square, that you already know from your past experience? All the angles are 90 degrees. That's right. Wouldn't you agree with that? If you just walked in the door and I didn't even mention square to you and I asked you, give me a definition of square, that's probably what you would have told me. All the sides are equal and all the angles are equal and all the angles are 90 degrees. You already knew that before you walked in the door today, didn't you? Okay? Well, here's a couple things that you might not have known. Let me see. Let me just make sure I go in order for what they're telling you. Square, square, square. Maybe that's all they tell you. Yep, I think. Well, let's just talk about the diagonals. Okay, the diagonals are a big deal here. And somebody said it earlier when I said, if all four sides are equal, what does that make it? And you said a parallelogram. That's very true. All right, and somebody said it was equilateral. That's very true as well. Okay, so those aren't wrong answers. I was just looking to see if you would say a rhombus, because we just finished talking about a rhombus. But let's take a look at the diagonals. They do a lot of stuff now, okay, on a square. Because really, a square is a combination of just about everything that we've talked about so far. Wouldn't you agree? A square is a parallelogram, isn't it? Because the opposite sides are equal to each other. The square is a rectangle. Why is a square a rectangle? Because it's got all four 90-degree angles, doesn't it? A square is also, what did we just talk about? A rhombus. A square is also a rhombus. So everything that's true about a parallelogram has got to be true about a square. Everything that's true about a rectangle has got to be true about a square. Everything that's true about a rhombus has got to be true about a square. So a square has got a lot of stuff that we know about a square. We know the opposite sides are equal. We know the opposite angles are equal. We know the consecutive angles are supplementary, right? We know that all four right angles are right angles because it's right. That's the definition of a square. It's part of it. What do we know about the diagonals, though? We know since it's a parallelogram, the diagonals bisect each other. We also know since it's a rectangle, square is a rectangle, that the diagonals are what to each other? Are equal to each other. Remember, the diagonals on a rectangle are equal. So these have to be equal to each other. So watch, if I said A, B, C, D. What could I say about AC? I could say AC is equal to what? BD. And we'll put an E right here. What else could I say? I could also say that AE is equal to BE, which is equal to DE, which is equal to EC. Couldn't I? All right, there's all kinds of stuff. What can I say about the angle here at angle E? It's perpendicular. It's a right angle because a square is also a rhombus, isn't it? So a square is a whole bunch of these different things. And so everything that's true about, everything's true about a parallelogram and a rhombus and a rectangle is also true in a square. All right. Look at these angles right here. Actually, without giving you any numbers whatsoever, tell me how many degrees that angle is right there, angle DBC. Tell me the degrees for that angle right there. Don't say it, Summer. Okay. What is it? This little angle right here, angle DBC. The whole big angle, ABC, is 90 degrees, but this little angle, just this one right here, that's not 90 degrees. What is 90 divided by 2? 45, that's right. So that is 45 degrees, right? Without giving you any numbers whatsoever, right? I told you this was a right angle. That's kind of giving you a number, isn't it? All right, but you had to know that. So if you know this is 90 degrees, what's true about this diagonal? It bisects that angle, doesn't it? So if I bisect 90 degrees, I split 90 in half, right? Which is 45. Of course, this is 45 as well. And this is 45. I could keep going all around this thing, couldn't I? So this is 90, 45, 45. There's so much stuff that we know about a square. And you thought a square is just a simple little thing. But you would have never known when you were a kid in middle school all this stuff about the diagonals and all that kind of thing. All right? But now, we're not in middle school anymore. And now we learned a whole bunch of stuff about it. Okay? And you know what they're going to do here, don't you? They're going to give you like 3x plus 2, 5x minus 1, and you're going to have to figure out, are they equal to each other? Is one maybe twice as big as the other? Solve for x, plug it back in, to find the angle or to find the length of the side. We've been doing this over and over and over again. Don't just get sucked into the thing where you just look at it and you say, well, I don't know what to do. I'll just set them equal to each other. It's not a good idea. All right? Make sure you look at it and understand what is going on. What's going on to get those angles and those sides. All right. I know you're bored to death, but if you could keep the sighing down to a minimum, that would be really nice. Okay? You can have a little more self-control than that. All right, so I'm going to give you a worksheet, and it's, I forget what the page number is, but it's section, what is this? 6.5. Okay, so I'm going to give you a worksheet 6.5. It'll be due tomorrow.